Welcome to Knowledge Base. Let us look at this question under gravitational force. The question says, the gravitational force between two bodies is 148.28 times 10 raised to power minus 11 Newton. If one of the bodies has a mass of 80 kg, what is the mass of the second body if the bodies are separated by a distance of 6 meters? We are given the gravitational constant G to be 6.6743 times 10 raised to power minus 11 Newton meter square per kilogram squared. Let's just sort out the parameters because that is how I like solving my problems, so we can pick the values much more easily. We are told that the gravitational force that exists between two bodies, F equals to 148.28 times 10 raised to power minus 11 Newton. One of the body has a mass of 80 kg. Let's call that M1, 80 kg. What is the mass of the second body? Let's call it M2. We don't know it. That's what we are looking for. The distance of separation between the bodies are, let's call it R equals to 6 meters, the distance of separation. And of course, the gravitational constant is giving us 6.6743 times 10 raised to power minus 11 Newton meter square per kilogram square. Please take note, gravitational constant is different from acceleration due to gravity. Gravitational constant is a constant value that deduces the amount of force that pulls two objects together under the influence of gravity. In our subsequent video, we shall look into how to get the acceleration due to gravity when we know the gravitational constant, but that is the story for another day. Now, let's dive right into this. We have to recall the formula. That is one thing with physics. You have to recall formulas to solve problems. The formula for gravitational force is giving us F equals to gm1 m2 all over r squared. It means the gravitational force is equals to the product of the two masses divided by the square of the distance separating them. And again, that is multiplied by the gravitational constant G. Here we know all the parameters except m2, which is the mass we are looking for. So in bit to make m2 subject of formula, we shall cross multiply so that we have gm1 m2 equals to fr squared. To make m2 subject of the formula, we will divide both sides by gm1 so that m2 will be equals to fr squared all over gm1. At this point, we can substitute our values. F being this, r being 6, and g as we have it here, we just put the values so that m2 will be equals to this 148.28 times 10 raised to power minus 11 for the f times 6 squared. R is 6, so we have 6 squared, r squared, all over g is given as 6.6743 times 10 raised to power minus 11 times m1 is given as 80. We put the value there, 80. At this point, we now have to use our calculators. The numerator, if you put this value into your calculator, it gives you 5338 times 10 raised to power minus 11. If you put the denominator into the calculator, it gives you 534 times 10 raised to power minus 11. 10 to the power of minus 11 will cancel out 10 to the power of minus 11. You just have to do 5338 divided by 534, and that approximately gives you 10 kg. It means the mass of the second body is 10 kg. It is that simple and interesting, and I believe you enjoy this. Now try this simple one that says determine the gravitational force between two masses of 150 kg and 600 kg separated by a distance of 4 meters. Given the gravitational constant here, and when you get the answer, please put it in the comments section. Thank you very much for watching this video. Endeavor to like and share this video to others. That way you keep encouraging us to make interesting content. Once again, thank you for watching and see you in our next video.